Let's go over the solution for problem 9.11 from your textbook. Let's do A first. The concentration of sodium hydroxide is double. But what the question is asking you is what happens to the rate of this reaction, SN2 reaction, when you double the concentration of the sodium hydroxide. Sodium hydroxide, to be more specific, the hydroxide ion is your nucleophile. And you know that the rate determining step for the SN2 reaction includes both the haloalkane and the nucleophile. So the rate law will depend on the concentration of both the haloalkane and the nucleophile. So if you double the concentration of your hydroxide ion is your nucleophile in this case, then you will also increase the rate of the reaction by a factor of 2. So for A, when the concentration of the sodium hydroxide is double, that means the rate will also double. Let's take a look at B. What happens to the rate of the SN2 reaction when the concentrations of both sodium hydroxide and 1-bromopropane are double? Let's go back to the Rayleigh law to answer this question. The Rayleigh law for the SN2 reaction depends on the concentrations of both the haloalkane and the nucleophile. So if you increase the concentration of the haloalkane by a factor of 2 and you also increase the concentration of the nucleophile by a factor of 2, that means that you will increase the rate of the reaction by a factor of 4. The rate will quadruple. Let's take a look at C. What happens to the rate of the SN2 reaction when the volume of the solution in which the SN2 reaction is carried out is double? When you increase the volume, you are lowering the concentration of each reactant. That means that you are decreasing the concentration of the haloalkane and the concentration of the nucleophile by a factor of 2. So that means the rate will be lower, will be slower rate, and the rate will slow down, will decrease by a factor of 4.